Good afternoon. It's 4 o'clock. It's webinar time. Welcome everyone to today's webinar on fire safety for electrical vehicles in indoor parking and charging facilities. We are delighted to have such a diverse audience joining us, including representatives from the fire safety industry, building design and engineering sectors, public authorities, and even mobility experts from across Europe and, if I see it well, beyond. My name is Martin Franken, and I'll be your host for this session, organized by the extinguishing section of Euroalarm, the European association representing the fire safety and security industry. Euroalarm has long been committed to promoting safety, security, and sustainability across Europe through publishing guidance documents, contributing to standards and collaborating with industry and authorities. Today's webinar is part of that ongoing mission, bringing together experts and practitioners to discuss one of the most topical issues in our field: how to ensure fire safety in environments where electrical mobility meets the built environment. Our keynote speaker today is Gert Hulsen, who is Vice Chair of the Extinguishing Section and who has been deeply involved in developing the Euroalarm guidance paper on fire safety for electrical vehicles in parking and charging facilities. A document that you can download, by the way, from our website. The rapid growth of electrical vehicles across Europe is transforming not just how we move, but also how we design and protect our buildings. And while EVs bring clear environmental benefits, they also introduce new safety considerations, particularly in underground and multi-story parking structures, where space, ventilation, and access are limited. At the same time, a number of myths and misconceptions about EV fire risk have emerged. And today we will take a closer look at the facts versus the myth. We will explore practical fire protection solutions and share best practices for safe and resilient infrastructures. Before we start, a few quick notes. Presentation will be around 30 minutes and it will be followed by a Q&A session where you can submit your questions through the chat at any time. We will make the slides as well as the recording of this webinar available after the event. And my question to you would also be, please keep your microphone shut or muted during the presentation so we enable Gert to do the best of his job. With that, it's my pleasure to hand over to our speaker, Gert Hulsen, who will guide us through the findings and the recommendation of Euroalarm's latest work. Gert, the floor is yours.
Yeah, thank you, Martin, for that kind introduction. Would be great if you start sharing the presentation so that I can take over. So now trying to take the control here. It works. Yeah, again, thanks for that very kind intro, Martin. And also from my side, a warm welcome to all participants joining us today. Yeah, I'm really delighted to share with you a topic, I think, of really growing importance in the future of our mobility. As said, fire safety for electric vehicles in indoor parking and charging facilities. Yeah, as we stand at the forefront of that transportation revolution, electric mobility is undeniable our future, I would say. And however, like any transformative technology, it brings, of course, new challenges and questions, in particular in fire safety. And at Euroalarm, we have been really working intensively on these challenges. And today, I will share with you our most important insight, facts, and best practice. So, Hobson, is it working here? Second slide. So, there was a copy. So, but before we dive deeper into the important topic, let me outline the scope of our discussion today. The Euroalarm guidance paper we are presenting isn't just about electric vehicles in isolation. We are taking a comprehensive look at the fire risk in parking facilities with charging infrastructure. What makes our approach different is that we are considering both the electric and the conventional vehicles. This reflects the reality of today's parking facilities, where we see, of course, a mix of different vehicle types. And our goal was to deliver guidance. There is some background noise. Hopefully not sleeping guy. Who is sleeping there? Can you hear that? Yeah. This reflects.
It should be fixed, Gerd.
Yeah, it's gone. Yeah, thank you. This reflects the reality of today's parking facility. We really see a mix of different vehicle types. And our goal is to deliver a guidance to develop scalable fire safety solutions that can adapt to various parking layouts and vehicle combinations. Now, to ensure that we are all speaking the same language, let's clarify some key terminology that will be crucial for our discussion today. When we are talking about electric vehicles or EVs, we are actually using an umbrella term that encompasses several distinct vehicle types. Let me break this down for you. First, we have the battery electric vehicles. These are what many people think as of pure electric vehicles running exclusively on battery power. Then we have hybrid electric vehicles, which combine both battery and combustion engine technology. Finally, there are these plug-in hybrid electric vehicles, which build on the hybrid concept, but also can charge directly from the electrical grid. So let us now first look on how these different vehicle types are shaping today's automotive market. The data from July 2025, collected here by the Austrian Federal Association for E-Mobility, tells that story of transformation. While hybrid vehicles are really experience remarkable growth, pure electric vehicles are showing steadily consistent progress. Meanwhile, we are witnessing a significant decline in conventional combustion vehicles. Looking at the numbers, battery electric vehicles registration have reached over 1 million units in a 7-month period, capturing now 15.6% of the market, up from 12.5% last year. Even more impressive is the hybrid segment, commanding 34.7% on the market. And the traditional combustion engines now represent just that 37.7%, which is a dramatic drop from 47.9% last year. So, with this market concept in mind, let us address some, as Martin said, common misconceptions about electrical vehicle safety. Our Euroalarm working group has identified 3 relevant myths that need to be analyzed and, when necessary, debunked with clear factual information. First myth: battery electric vehicles catch more often fire than vehicles with combustion engines. That's true, right? If we were to ask 100 people on the street about a vehicle and vehicles fire risk, what would they say? The public perception is shown here on the next slide. Yeah, this outcome was really to be expected, given the dramatic reports circulating on social media. It is not surprising that battery electric vehicles received the worst ratings. According to the 2023 survey, 35% of respondents clearly identified that battery electric vehicles pose the highest fire risk. Interestingly, look at that, hybrid powered vehicles appear to be perceived as the safest drive type in public eye. But does this reflect the reality? No. The data tells a totally different story. Battery electric vehicles are not the fire hazard that many believe them to be. In fact, statistics show that hybrid vehicles have the highest likelihood of catching fire, while battery electric vehicles demonstrate a significantly lower fire incident rate, even a lot safer than conventional vehicles. So, battery electric vehicles do not catch fire more often than vehicles with internal combustion engines. This brings us to another common concern, the fire load of electric vehicles, and the second myth. Yeah, the traction battery in battery electric vehicles make them carrying the highest fire load of any vehicle type. It's obviously right. Yes, a lithium-ion battery has high energy density, but the total fire load of a vehicle composed of many components, not just the battery or the fuel tank. Let's analyze this in more detail on the next slide. Yeah, several expert organizations, including DEKRA, have investigated the fire load of modern vehicles. DEKRA, shown here, conducted a calculation for a compact class vehicle. Yeah, while the battery electric vehicle is certainly several hundred kilograms heavier due to its battery, does this dictate the fire load? No. This calculation clearly shows that the fire load is primarily influenced by the amount of plastic and the load of the tires, which account for approximately 80% of the total fire load, regardless of the drive type. Yeah, and this leads us directly to the fact that debunks the second myth. The total fire load is comparable regardless of the drive type. And it is not a question of whether an EV has a higher fire load, but rather how this fire load behaves in event of fire and what specific hazards arise from the respective materials. So the focus should therefore be on the different phenomena and the resulting requirements for fire protection, not on a perceived higher total fire load, with direct connection to the third myth. The notion that battery electric vehicle fires cannot be extinguished due to the large traction battery. That's true, isn't it? Yeah, a truly critical aspect that makes extinguishing electric vehicle fires so challenging is both a characteristic of the traction battery itself and its often problematic positioning, typically beneath the passenger compartment. So firstly, we have the high energy density of electrochemical energy stored within the traction battery. This can lead what we call thermal runaway propagation, the spread from thermal runaway from cell to cell, potentially lasting for a very, very long time. Secondly, the battery's positioning, often, as said, deep beneath the vehicle floor, makes directly cooling for emergency responders almost impossible. A firefighter once described it very vividly to me. It's like trying to put out a room fire by sprinkling water on the roof of the house. You simply cannot get to the source of the fire directly. So, nevertheless, and this is an important message from fire services, an electric car fire is fundamentally extinguishable. But what we can definitely state, however, and what there is a broad agreement on, is that the water demand for EV fires is orders of magnitude greater than for vehicles with internal combustion engines. So the key message is here. While EV fires present different challenges, they can be effectively managed with proper equipment and procedures. It's about understanding and adapting to these differences rather than fearing them. So, after having debunked the most important myths, I would like to return with you to the foundation of every fire protection concept. The central basis, and we cannot emphasize this enough, is the careful identification and assessment of existing or anticipated risks. So let's look especially what we can find in parking garages today. What we are essentially dealing with are the three elements. First, we have the modern vehicles that are continuously growing in size. Then we have a steadily increasing proportion of electric vehicles, both hybrid and pure electric driven ones. And the increasingly extensive charging infrastructure required for these vehicles. So let us look at these three elements and their specific risk more closely on the next slides. Yeah, let us start with a look what we know about the fire risk of modern vehicles. First, the vehicle size. Modern cars are getting larger and heavier. This makes access for emergency services more difficult and significantly complicates extinguishing measures in confined parking environments. Second, as said, the plastic content. The high and continuous increasing proportion of plastic in modern vehicles significantly increase the fire load. And this can lead to rapid fire spread, intense smoke development, and the massive release of toxic gases. Third, the challenge of the parking decks. Multi-story car parks and underground garages are particularly critical. Here we often have limited ventilation, which makes smoke extraction difficult, and the risk of spreading between levels as well as the impairment of the building structure is real. And last but not least, we are seeing still the small parking lots for the older cars. So when vehicles are parked close to each other, close together, this promotes rapid fire spread. In addition, escape routes and rescue access can be obstructed, and access space for emergency vehicles is significantly restricted. So let us now look on the key characteristics that makes EV fires unique and sum up why they are critical for implementing appropriate fire protection measures in parking areas. Let me begin with the perhaps most well-known phenomenon, the so-called battery thermal runaway. Imagine what happened there. A single battery cell overheats and triggers a chain reaction. This reaction can spread like a domino effect to adjacent cells. This is particularly important to understand, can persist over a very long period. Another important aspect we must consider is the generation of additional specific toxic and flammable gases during a battery fire. This combination poses a particular risk and challenge both for the people in the vicinity and for the firefighting services. Particularly critical and tricky is the phenomenon known as stranded energy, which refers to the residual energy remaining in the battery. This can lead to, and this is a significant difference to conventional vehicle fires, a seemingly extinguished fire can reignite itself hours later. And as we have already discussed, electrical vehicle fires are characterized by a significant longer burning duration. They require not only adapted extinguishing methods, but also considerable larger quantity of extinguishing water. This naturally has direct implications for the dimensioning of our fire protection facilities. And finally, I would like to point out an often overlooked aspect, the risk during active charging. These fundamentally differ from those of a passively parked vehicle, as the charging infrastructure itself represent a potential ignition source. To put this in a perspective, we all know approximately 1/3 of all fires in buildings are caused by electrical equipment and installations. This is a statistics we really have to take very serious. And last week, there was an incident where a hybrid vehicle, just an example, caught fire while recharging in a parking garage in Tampere, Finland. And just before the meeting, it was Paul informing me that we had a similar case in Belgium last week. So That is, we must take these special characteristics into account when designing modern fire protection solutions for parking facilities. So, yeah, now let us have a closer look on the fire risk associated with the charging infrastructure. First of all, we have installation errors. And another statistic is showing that approximately 1/3 of all electric fires is resulting from faulty installations, typically caused by improper wiring, overloaded circuits, or inadequate grounding, or the use of unsuitable materials. Then, of course, inadequate equipment safety, use of devices that do not meet the current safety standards, can overheat or cause short circuits, posing a significant risk. Then, of course, lack of maintenance. Here we see loose connections, damaged cables, or corrosion that can lead to heat up and fires. These issues are often caused by mechanical wear, environmental factors such as humidity or temperature fluctuations, but also by animal damage. So, and finally, missing emergency shutoffs. As without a quick emergency shutoff, the power supply cannot interrupt it in time during a fire or in event of a technical defect. This significantly increase the danger. But before we now dive into the fire protection objectives, especially in parking areas, I want to highlight a key point. From our point of view, the charging station are undoubtedly among the most critical areas when it comes to the fire risk. Hybrid vehicles, known for having the highest fire risk among all vehicle types, are often parked there closely together to maximize the limit space. On top of that, the previous outlined challenges of the charging infrastructure, ranking from installation flaws to equipment and maintenance issues, further amplify the potential danger. And this combination makes the charging zone a focal point for proactive fire protection. So, after having analyzed the risk, let us recall what our paramount protection goal in fire safety, including in parking garages, is: the safety of human lives. All our fire protection methods are primarily aimed at protecting human life. Specifically, this means safe evacuation of people as the highest priority. Escape routes must be clear and safely accessible. We must effectively limit fire spread to minimize damage and gain time for evacuation. The structural integrity of the building must be maintained for as long as possible to prevent collapse. And finally, we must enable safe intervention by fire services. Emergency responders must be able to do their work without unnecessary risk. These 4 points form the foundation of any effective fire protection strategy. And unfortunately, it's concerning that these fundamental safety measures are not yet universally adopted everywhere. So, what do we need to achieve that? As always, a holistic approach to fire protection is needed. When we talk about holistic, we mean combining architectural, technical, and organizational measures into a comprehensive safety strategy. Let us break this down in the key components that work together to create a robust fire protection system. First, the prevention is always our starting point. As the saying goes, the best fire is the one that never starts. This includes proper installation and maintenance of the charging infrastructure, regular inspections, and a clear safety protocol. Second, we must ensure clear evacuation routes. This may sound basic, but it's absolutely crucial. In an emergency, every second counts. and a clear escape route can mean the difference between life and death. Third, we implement automatic fire detection systems. Early detection is crucial. The sooner we detect a fire, the better our chance of controlling it or extinguishing it early. Fourth, we employ active fire suppression systems, such as sprinklers or water mist systems. These primarily serve to control and contain the fires, preventing the fire spread to adjacent vehicles. And this is particularly important in parking facilities where vehicles are often parked very close to each other. Just to remind, in the parking garage at Luton Airport, there was neither one nor the other. Oops, so finally, we install, of course, emergency shutoffs for the chargers. This is a specific measure for electric vehicle charging areas, allowing us to quickly cut power to the charging stations in an emergency. And finally, we implement, of course, smoke extraction systems. These are crucial in enclosed parking facilities where smoke can quickly become a serious hazard, potentially blocking escape routes and hampering firefighting efforts. Each of these elements plays an important role, but only their integration into a single coordinated systems provide truly effective fire protection. Remember, these measures do not work in isolation. They complement and support each other, creating multiple layers of safety. So, as we are concluding my presentation, it is becoming clear that fire protection requirements for parking garages are undergoing fundamental changes. While this transformation is largely driven by the increasingly electrification of our vehicle fleet, the root cause lies in the introduction of the modern vehicle concepts, regardless of their drive type. I hope that today's discussion has demonstrated that these challenges are entirely manageable when we adopt a comprehensive, holistic approach accordingly. Let me summarize the key points and proven practices. First, we learned that both electric and combustion vehicles present specific risk requiring tailored safety measures. This isn't an either-or situation, but rather an both-and approach to safety. Second, while electric vehicles do not inherently pose a higher fire risk than conventional vehicles, the specific characteristics of EV fires do require adapted yet completely feasible extinguishing strategies. It's actually the modern vehicle in general, with the increasing size and plastic content, that contribute to the higher fire load of today's vehicles. This is why we can no longer rely on traditional solutions and need adapted garage planning. Third, preventive measures, especially regarding charging infrastructure, play an equally important role in ensuring safety. Fourth, we highlighted the significance of rapid response. Quick intervention and automatic fire suppression systems at neuralgic points are crucial for limiting fire damage and effectively supporting our fire services, because every minute truly counts. Looking to the future, it's not surprising that the success lies in seamless integration of modern fire protection concepts into both existing and new parking infrastructures. The example of electric vehicles demonstrates the need for the continuous development of our safety standards, thorough training and preparation of emergency teams, and of course, a regular review and adoption of protective measures. So, the future-oriented safety planning is paramount as the technology rapidly evolves. ongoing research and adaptation to new vehicle technologies are essential for the future of fire safety. This means we must remain agile and continuously adapt. Through this systematic approach, we can confidently ensure parking garage safety regardless of the vehicle type, making us well prepared for the exciting future of our mobility. Yeah, that leaves us with a very important questions, and we discussed that in our working group. Can we realistically implement this comprehensive approach in all parking garages? Yeah, and we came to the answer in most cases, probably not. So we had to answer the question where we start. And within the Euralarm working group, we have agreed that the resources should be prioritized where they have the greatest impact. And our assessment was clear, or is clear. The area around the charging stations should be the first and foremost focus. And said that, a comprehensive automatic fire detection system, of course, should be considered as a basic standard in every parking garage. So that brings me to the end of my part of the presentation, and I hope I was able to give you a good overview of the challenges and solutions in the field of fire safety for electric vehicles and debunk the most important myths. Yeah, now it's time for your questions, and I'm really curious to hear what's in your mind, and I look forward to a lively discussion. Yeah, please continue to use the Q&A session. I do not know already how many questions we already have to submit your questions. Thank you.
There are questions, Gert. Perhaps I can discuss, present them to you, and then you can answer if that's okay for you. One question from Mr. Carl Gustav Jonsson. The statistic that you showed in slide 9 was were they from Germany or from Europe in general?
About the what was it, 9? Slide 9 is the likelihood of EVs or different drive types catching fire. No, this is figures which are coming from North America, Scandinavia, Germany, also say it worldwide. Yeah, and the best statistics we have from Scandinavia, but also from North America. Yeah, easy to make a fact check. Yeah.
Another question, let me see, is there a certain technology you can advise for an early detection? Can thermal cameras detect a starting fire? Are there certain sensors? What advice do you have?
Yeah, I can maybe go just 2 slides back, because it's not so high sophisticated what is needed to detect a car fire. It is, I would say, fail-safe point type detectors, smoke detectors, which are doing the job. It is not needed to have thermal imaging systems for fire locations. So the point type detectors are doing a very proper job there. Yeah.
Okay.
Other standard smoke, temperature, multi-criteria detectors, as we presented last week, Martin.
Yeah. Okay. Another question, Gert. You mentioned the hybrid vehicles, but there's also a new generation of vehicles that might rise the hydrogen fueled vehicles. Will they influence the future fire safety strategies, or is that a topic for another guidance document of Euralarm?
Yeah, of course, it's a different drive type. In the end, it's an electric vehicle, but it's just that we have a hydrogen as a fuel stored there. But as the fire safety or the level of fire safety in EVs are showing, I expect that hybrid vehicles will also reach at least that level of safety. It's just the storage and the handling of the hydrogen, which may be giving a challenge. But I do not expect fuel stations in parking garages, at least.
Yeah. Okay. Another question from Katja Alves. There are some automatic suppression system recommended to. Are there some automatic suppression system recommended to EV indoor parking garages, Gerrit?
Also we see, of course, we have standard sprinkler systems doing the job, but what we learned is that it is giving you an advantage if you activate the water suppression system, a sprinkler or a water mist system by using a fire alarm system with proper smoke/multi-criteria detectors to be faster, because it takes a while until the sprinkler bulb really is able to detect and activate the sprinkler head. So, yeah.
There's an interesting remark from Patrick van Liem. I once saw a mobile sprinkler to glide under the car. Interesting, even cars with a water connection to suppress the fire of the battery. Just to show that the technology evolves. That's more or less what is said, I think. Are there any misconceptions about the building structure, Gerrit? How should charging stations in parking structures be designed to minimize fire risks? You already mentioned some of it, but
yeah, of course it is. Of course, a proper installed charger and proper maintained charger is not bringing a huge risk into the building. The challenge is missing maintenance, faulty cables. I would say maintenance around the chargers is doing a lot, to improve fire safety. And then, of course, we see that really around the charging stations, especially the hybrid vehicles, maybe the older ones, maybe using old cables, bringing additional risk. So, as said, at these neuralgic points we were identified in the working group as a neuralgic point, a water suppression system would make sense from our point of view.
Okay. A question in the Q&A, can fire detection be helpful for improving the existing garages?
Sure. The earlier we detect the incident, the better the chance to successfully fight the fire. And we have seen incidences where automatic fire detection system was not in place, just these manual call points, and it take a while until people decide, okay, this is now time to call the fire services. And every minute counts. So active automatic detection system are really bringing a huge advantage and improving fire safety.
One last one, I think you mentioned the importance of rapid response. How do you see the role of collaboration between manufacturers, fire services, and regulators evolving to allow that rapid response?
Sorry, can you repeat that question?
Because you mentioned the importance of a rapid response. How do you see the role of collaboration between manufacturers, fire services, and the regulators? Can they help evolving towards a more rapid response?
Of course, there would be a chance because a modern car knows, of course, about the developing battery issue. And if we would have, let's say, a communication protocol allowing us to get that status of the vehicle directly communicating with the building infrastructure would be great. But to get that.
One more question for you to answer, Gerrit, from a question from Dennis. What is the logic behind creating an EV charging hub or zone if the risk of a fire for ICE and hybrid vehicles is higher than EVs? How do you characterize that?
Because we said the chargers, the electrical systems are bringing the risk, not the EVs itself. Of course, we saw that the hybrids having the highest risk, maybe due to the age. We do not know why hybrids are really showing that characteristic, having the highest likelihood of catching fire. Maybe the age, maybe bad maintenance. But we see the infrastructure, the cabling, especially the cabling around this charging systems, maybe unmaintained chargers as the risk. Yeah.
Okay.
That's why.
Any more questions? Now is the time. If not, then I would like to thank you, Gert, for your presentation. And of course, a big thanks to our audience. As mentioned in the beginning, the recordings of this webinar will be available as of tomorrow, so that you and your colleagues can view the webinar once more. Please also visit our website, where you can find the guidance document on fire safety for electrical vehicles in parking and charging facilities in several languages. And with that, I would like to say thank you again, and have a wonderful evening. Thank you.
Thank you. It was a pleasure.